This is Bob Capetta from the University of Illinois at Chicago, and this is Math 121 Pre-Calculus Final Exam Review, Part 1, Problems 9 through 14. Our first question is 4 to the x plus 2 equals 1 over 64. There's a common base here. You could use 4 or you could use 2. I prefer to go to the smaller number. So I'm going to think of 4 as 2 to the second power, and 64 is 2 to the sixth power. When you raise a power to a power, you multiply the exponents. So on the left hand side, we're going to get 2 to the 2 times x plus 2 power. And on the right side, that is 2 to the negative 6 power. Well, in this case, the exponents must be equal, so 2 times x plus 2 must equal negative 6. 2x plus 4 is negative 6, subtracting 4, 2x is negative 10, and x is negative 5. Next up we have 2 to the x plus 6 equals 16 to the 2x. 16 is 2 to the fourth power. Again, when we raise a power to a power, we multiply exponents. So 2 to the x plus 6 is 2 to the 4 times 2x, or 2 to the 8x. When this is the case, x plus 6 equals 8x. Let's subtract x from both sides. It'll give us 6 equals 7x. When that happens, then divide by 7. 6/7 is x. Next example, we want to find log base 2 of 1 over 32. I'd like to introduce another number, or a variable. So I'm going to say log base 2 of 132 equals y, and then the goal is to solve for y. Log base 2, the base is 2, y is the exponent. 2 to the y equals 1 over 32. 32, 2, 4, 8, 16, 32, that's 2 to the negative 5, 1 over 2 to the fifth. So 2 to the y is 2 to the negative 5, therefore y is negative 5. Next up is log base 81 of 9. Again, I'm going to introduce y and say log base 81 of 9 is y. So then 81 to the y equals 9. But what is 81? 81 is 9 squared. 9 squared to the y is 9 to the 1. 9 to the 2y, raise a power to a power, multiply exponents. 9 to the 2y is 9 to the 1, and 2y is 1. Divide by 2, y is 1/2. Next is the natural log of 1 over root e. Remember, natural log is log base e. And again, I want to introduce a variable for this problem. So natural log of 1 over root e is y. But natural log is log base e. So log base e of 1 over root e is y. So then e to the y is 1 over root e. Root e, of course, is e to the 1/2. So e to the y is 1 over e to the 1/2. E to the y is e to the negative 1/2. Y is negative 1/2. Conclusion, natural log 1 over root e equals negative 1/2. Next we have log of 5x plus 15 is 2. Common log, the base is actually 10. So let's put that in for emphasis. Now 10 to the second power equals 5x plus 15. 10 to the second power is 100 is 5x plus 15. Subtract 15 from both sides. 85 is 5x. Divide by 5 and we get 17 is x. Now make sure that's an acceptable number. 17 times 5 is 85. 85 plus 15 is 100. We can take a log of a positive number of positive 100. And indeed, log base 10 of 100 is 2. That's correct. Next example is log base x of 27 is 3. So x to the third power equals 27. 27 is 3 to the third power, so x equals 3. Good enough. Next we have a fan blade is 2 feet long and makes 200 revolutions per minute. We want to find the angular speed of the tip of the blade and the linear speed. Angular speed is measured in radians per unit of time, so in this case radians per minute. So to get our angular speed, we're going to start with 200 revolutions per minute. We want to convert that to radians per minute. So 1 revolution is how many radians? 1 revolution is 2 pi radians. We need revolutions to cancel, so revolutions on the bottom, radians on top. 2 pi radians is 1 revolution, so revolutions will cancel. We have radians per minute. 200 times 2 pi, 400 pi radians per minute. Linear speed is measured in inches, feet, miles per unit of time, in this case feet per minute. So we're going to again start with 200 revolutions per minute, but we've got to convert revolutions to feet. And that's done by looking at circumference. So the circumference of a circle is 2 pi times the radius. Radius here is 2 feet long. So the circumference is 2 pi times 2 feet, or 4 pi feet. So 1 revolution is 1 circumference. 1 revolution is 4 pi feet. So recognizing that fact, we can go ahead and find our linear speed, starting with 200 revolutions per minute times. We want to convert revolutions to feet. 1 revolution is 4 pi feet, since the circumference is 4 pi feet. Revolutions on the bottom, feet on the top. 4 pi feet is 1 revolution. Revolutions cancel. 200 times 4 pi should be 800 pi feet per minute. And that is our linear speed. Next we have a windshield wiper is 18 inches long and swings through a 120-degree angle. So we have to visualize this. The radius is 18 inches. The angle is 120 degrees. What we have here is a sector, like a piece of pizza cut through the center. We want to find the distance traveled by the blade. So through that, what will that be? That's a fraction of a circle. So the distance is that fraction of the circle times the circumference of the circle. That's going to give us our distance. The fraction of a circle is 120 degrees divided by 360 degrees times the circumference of the circle, which we saw is 2 pi times the radius. 2 pi times the radius of 18 inches for our windshield wiper blade. So simplifying that, 120 over 360 is a third. 2 pi times 18, 36 pi. 1/3 times 36 pi. 12 pi inches. Now the area swept out by the blade, again, thinking of a piece of pizza cut through the center, the area of that is also going to be the fraction of the circle times the entire circle. So the fraction of the circle here again is 120 divided by 360, but the area of the circle is pi r squared. Recall that, pi times the radius squared. So our area here is going to be 120 degrees divided by 360 degrees times pi times the radius squared. 18 squared is 324. So you have 324 pi square inches. 120 degrees divided by 360 degrees is a third. And we get 108 pi square inches. Next we have cosine of negative pi over 6, fourth quadrant angle. Negative pi over 6 is in quadrant 4. In quadrant 4, cosine is positive. The reference angle is, of course, pi over 6. So putting that together then, cosine of negative pi over 6 is positive in the fourth quadrant. Reference angle is pi over 6. Cosine of pi over 6 is root 3 over 2, and the answer is positive root 3 over 2. Next we have 7 pi over 6, which is in quadrant 3. If that's the case, we know sine is negative in quadrant 3. Reference angle, let's see, 7 pi over 6 is more than pi, pi over 6 more than pi, so the reference angle is pi over 6. So sine of 7 pi over 6 is negative, since it's in quadrant 3, sine of the reference angle. Negative sine of pi over 6. Sine of pi over 6 is a half, negative 1/2. Next we have tangent 8 pi over 3. Now that's more than 2 pi. We're going to get a coterminal angle by subtracting 2 pi. So 8 pi over 3 minus 2 pi is 2 pi is 6 pi over 3. That's going to give us tangent of 2 pi over 3. Which is more than pi over 2, that puts us in the second quadrant. 2 pi over 3 is in quadrant 2, and indeed, tangent is negative in quadrant 2. Reference angle, to get from 2 pi over 3 to pi is another pi over 3, so the reference angle here is pi over 3. So we need a negative tangent of pi over 3 once all this is taken care of for us. And the way I think of that is sine of pi over 3 divided by cosine of pi over 3. So with the negative sign in front. Negative sine of pi over 3 divided by cosine of pi over 3. Negative root 3 over 2 over a half, which of course finishes up with negative root 3. Next we have inverse cosine of negative root 3 over 2. We have to think about the range. The inverse cosine's range is quadrant 1 and quadrant 2, 0 to pi. Whereas inverse sine and inverse tangent are negative pi over 2 to pi over 2. Keep those in mind. I'd like to add an angle, so we'll say the inverse cosine of negative root 3 over 2 is theta, which means cosine of theta is negative root 3 over 2. So if we ignore the negative sign, cosine of theta is negative root 3 over 2. The reference angle we get there is pi over 6 again. But my range is from 0 to pi. In the first quadrant, cosine is positive, so I've got to bounce that to the second quadrant. So my answer will be pi over 6 in the second quadrant, or pi minus pi over 6, which is going to be 5 pi over 6. So the inverse cosine of negative root 3 over 2 is 5 pi over 6. Next we have arctangent of negative 1, and the range of the arctangent is from negative pi over 2 to pi over 2, not including the ends, of course. Let's add theta. Arctangent of negative 1 is theta, which means negative 1 is tan theta. Reference angle is pi over 4, because tangent of pi over 4 is 1. And tangent is negative on this range. That would be in quadrant 4. So we're going to have to think about pi over 4 in quadrant 4, but in this range, that of course is going to give me a value that is negative pi over 4. So the inverse tangent of negative 1 is negative pi over 4. Next we have inverse sine of root 3 over 2, and the range of the inverse sine function is negative pi over 2 to pi over 2. We're going to add theta. Inverse sine of root 3 over 2 is theta, so root 3 over 2 is sine theta. Reference angle is pi over 3, but we're in quadrant 1, so that's not a problem. So the answer is just theta is pi over 3. The inverse sine of root 3 over 2 is pi over 3. And that concludes this lesson.